Here we go. These, most people did really well in these derivatives. Some people forgot chain rule here and there, nothing too big. If you don't have your derivatives down though, I mean, you're definitely not studying enough, all right? You need to have these, make flashcards, get these down. The derivative of an ln is 1 over root x plus 1 times the derivative of what's inside. That's 1 over 2 root x times secant. We're doing the product rule here. Plus ln root x plus 1 times the derivative of secant, which is secant x tangent x. Okay? Again, that's product rule. Guys, when there's multiplication, you've got to use product rule. Number 3. You drive that. This is quotient rule. You get low, d high. The derivative of arc sine, which so many of us do not know, you have to memorize, is 1 over the square root of 1 minus x squared. Minus arc sine x times derived cotangent, which is negative cosecant squared of x, all over cotan squared x. Okay? Get those rules down. The derivative of this, derivative tangent, is secant squared 5 to the 3x, so that stays the same. You derive the 5 to the 3x. The derivative of an exponential is ln to the base times the same thing times the derivative of the exponent. A lot of people miss that 3 there. Yeah, super easy to do, not a huge deal, right? It's like a -1, 2 on the test grade if you're thinking about that. But it is there. You got multiplied derivative. What's up, Robert?
For number 2, how do you see ln?
There is no, what do you mean number 2? Oh, up here?
Yeah.
Like how did I derive it?
Yeah, like after secant, you have ln of...
Because it's plus, so we derive the ln here, right? Times secant. Then we leave the ln, and then we derive secant. Cool, it's product rule, right? And then number 5, the derivative, not a lot, but a handful of people are really confusing exponentials and logs. They're different things. They're tied together, but they're not the same thing. It's like plus and minus. If you saw a plus sign, you want to turn it into a minus sign. You can't just turn a log into an exponential. Like they're different. The derivative of log base 4 is 1 over ln 4 cosecant. And then we multiply by the derivative of what was inside of there, which was cosecant, which gives us that. Okay? Another thing to point out, a handful of people are treating this like it's multiplication. Be careful whether it's multiplication or something's inside of something else. Okay? You can't just have a log base 4 times cosecant. It has to be of x, or there has to be something in it. If that was multiplication, it would look like this. Log base 4 of x times cosecant x. That's multiplication. All right? Be careful if it's inside of it. That's the chain rule. All right. Let's move on. A lot of people didn't like this one for a very simple thing they messed up. You ready? I want the second derivative of this. The derivative of the left side is 5. The derivative of the right side, so many people messed up this derivative. That's a product. So we have to use the product rule. Okay? The product rule says, derive the first, leave the second, plus, leave the first, derive the second, y prime, or dy dx, whatever you want to write there. Plus, the derivative of y squared is 2y, y prime. You got a lot of people making really simple mistakes here, but if you don't get that, you're not going to get the second derivative. We're going to move over the 2xy. That's going to equal x squared plus 2y, and we're going to factor out the y prime. Okay? And that means y prime is... So if you don't have this correct, you should be writing this down somewhere. Cool. So if you got here, I gave you 5 points automatically. All right? Then we had to derive that again. So the second derivative, which you could write as y double prime, but really we should be using this. I'm just being lazy. D squared y over dx squared. This is the quotient rule. So it's low, d high. 5 turns into a 0. Okay? So we're deriving negative 2x times y. So the derivative of negative 2x is negative 2y. It should be a plus, but it's really going to be a minus. Okay? We leave the 2x and we derive y. So I should really put a dy dx right here, or a y prime. Is everybody okay with that? But because I'm going to make you plug in what y prime is, let's just put what it is right here. That's a 2. Is that okay? That's low d high. Minus high d low. But that's 2x plus 2y prime. But rather than writing y prime, I'm going to write what y is. Or y prime is, I mean. Which is 5 minus 2xy. Cool. So that looks like a big nightmare. We're not going to simplify it. We're going to leave it like that. Okay? Questions? What I was looking for that? Tangent lines are x, y, slope. Guys, we're allowed to have weird numbers here. I think that messed with you, some of you. If x is 2, first thing I'm going to do is find y. Y is root 2 ln 2. That's it. It's plugged in 2. So my tangent line has to be y, I messed up, minus root 2 ln 2 equals something x minus 2. Okay, you at least should have got there. I didn't even require any calculus. Then we're going to derive it. But because there's multiplication, this is the product rule, which a lot of us missed. So we get the slope, dy dx is 1 over 2 root x ln x plus root x over x. And all we need to do is plug a 2 into that. That's what the slope of our tangent line is. That's that with a 2 plugged in. So you don't even need to simplify it. I'm going to write that as ln of 2 over 2 root 2 plus root 2 over 2. I'll just plug 2 into the derivative. That's it. What's up, Justin? So we're doing the product rule, right? So this is the derivative of root x times ln x, right? And then we need to leave the root x and derive ln of x, which is 1 over x. And I just put it underneath of it, okay? All right. Here's number 8. Please stick with me on number 8. So many people miss this because of simple things. All right? If x is 0, I need to find y. Stick with me here. If you plug 0 in, you get e to the 0 minus 2y equals 0. That's not calculus, that's plugging in 0. Here's a fun fact. Anything to the 0 power is 1. So e to the 0 is not 0, which so many of us believe. It's 1. And if you solve that, you get that y is a half. Which means for our tangent line, we have that. Okay? So I was looking for, did you find y? Or did you attempt to find y? And then we need the slope, which is the derivative. So we derive this thing. The derivative of an exponential is of e to a power is the same thing times the derivative of the exponent. That's the chain rule, right? We've done a bunch of those. The derivative of the exponent, which is x times y, that's a product. We derive x, that's 1 times y, plus leave x, derive y. Minus, so that's the derivative of e to the xy, minus 2 dy dx equals 6. How we doing? Guys, we could solve for dy dx here if we wanted to, but we could also just plug in the y and the x values that we know. I know x is 0. Look what that does. That gives me e to the 0, which is just 1. It gives me 1/2, what's y, plus 0 dy dx, that goes away, minus 2 dy dx equals 6. Look what, that's so simple. That's 1 times 1/2 plus 0 minus 2 dy dx equals 6. That's what that boils down to. Let me know if you don't see that. Again, this e to the 0 is just 1. This is just a big 0. All right? And if you solve that, look, we're going to do minus a half. I really think we should use fractions. 6 minus a half is 11 halves. And then we're going to divide by negative 2, which is the same thing as multiplying by negative a half. Okay? So we're multiplying this by negative a half. That cancels that out. We're going to multiply this by negative a half. And you get that the slope is negative 11/4. But again, even if you messed up somewhere in there, like I'm giving you most credit, I just need to see you're doing the steps. You miss a negative. If you, I don't know, some of y'all weren't doing any of this stuff. We've done a bunch of these. Okay? Anyway, that's that. Show me the work. Let's keep going. I changed this. This was what, 61, right? I was asking for the horizontal and the vertical tangent lines. I want this to be organized. I want to be able to see what you're doing. I want you to label them, all right? But to find horizontal and vertical tangent lines, we need the derivative to be 0 for horizontal and undefined for vertical. So we derive it. And we get this. That's a 16y there. A couple people, when you drive negative 61, that's just 0. If you leave it negative 61 there, it's wrong, and it's going to mess everything up really badly. Okay? If you solve that for y prime, hope we're okay, we get 54 minus 18x over 8y plus 16. All right? So, to get horizontal, I need y prime to be 0. That's going to happen when 54 minus 18x is 0. And that happens when x is 3. Look how I labeled it. Horizontal. I showed my work. X equals 3. And a lot of times that's totally fine. But I asked for the actual equation, so we got to find y. Which means I got to plug x back in, okay? If you plug x back into here, you're going to get 27, 81, plus 4y squared, minus 162, plus 16y equals negative 61. And if you rearrange that, which seems like a lot, but I hope it's not too bad, you get 81, that's negative 81, plus 61, what's that, 20, minus 20? If you got here and then couldn't solve this, please pay attention. You should be able to solve a quadratic. We can divide everything by 4. We're trying to find where this is 0. This is the same thing as this. And that factors into y plus 5, y minus 1. So we get that y is either negative 5 or y equals 1. And those are the horizontal lines we're looking for. The equation of a horizontal line is y equals. Okay? To find the vertical, it's very similar. But for vertical, I'll do that up here. I need dy dx to be undefined. That's going to happen when 8y plus 16 is 0, which is when y is negative 2. And if y is negative 2, that turns, so we got to find x because we want the vertical lines. That's x equals. So we're going to plug in negative 2 for y. That's going to give me 9x squared plus 16 minus 54x minus 32 equals negative 61. And then that's just a quadratic. We just got to get this in the right form to solve it. So we have negative, what's that, negative 16 plus 61, is that 45? I think it's 45. We can divide all of that by 9. So this worked out really nicely here. And that factors into x minus 5, x minus 1. So the answers to that are x equals 5 and x equals 1. And it's just coincidental that y and x both have a 5 and a 1 in them. That doesn't have to happen. So that's how you do that. All right. And to round this out, number 10. I just want you to write the limit definition here. That's it. Some of y'all were trying to derive it. I just want to know that you know what the limit definition looks like. That's this. The limit as h approaches 0 of cosine. This becomes x plus h squared minus cosine of x squared over h. That's all I'm looking for there. So many people are writing this so weirdly. Look, please take a look at that. Limit as h goes to 0 of that thing. There's no f of x in there. Some are putting weird f primes in there and stuff. That's the definition of the derivative right there. Okay? Some of y'all have some semblance of what it is, and you're throwing all kinds of weird junk in there. This one. All the x's become x plus h's. We've done this a bunch. Minus in parentheses. F of x all over h. That's all we're looking for those. All right. And last one. Tell me if these are differentiable at 1. That just means do the functions meet? And if the functions do meet, do the derivatives meet? Okay? So for this very first one, what you're really doing, and I accepted a lot of sloppy answers here really, because I get what you're saying, but you're really checking this. The left-hand limit as you approach 1 is 4. That means I plugged 4 into the top function when x is less than 1. That's what's going on there. The right-hand limit as I approach 1, not 4, is 0, gang. That's something a lot of us didn't know either. When you put a 1 into that bottom function, we should know this. Cosine of pi over 2 is 0. These are not equal. Because they're not equal, f of x is not differentiable because it is not continuous. That's all you got to do. You don't need to drive it or anything. Does that make sense? Good talk. Okay. And the second one, is it differentiable or not? You got to make sure it's continuous. So the first thing we do is we plug in 1 to the left side, which is going to be ln of 1 plus 1. That is 0 plus 1. That is 1. We're going to plug in 1 to the right side. If you do that, you get 1. Y'all can see that, right? Those are equal. And I also know, because there's an equal bar, that equals f of 1. So f of x is continuous. That's our definition of continuity. The left limit, the right limit, and the function value, which is this, are all the same. So we got to check the derivatives. F prime of x. So a lot of people miss this here. The derivative of this is 2 over 2x minus 1 plus 1, because you got to do the chain rule there. So when you drive this ln, it's 1 over 2x minus 1 times 2. And the derivative of the parabola is easy, or the quadratic is easy. Okay? So we have the limit as x goes to 1 from the left for f prime. This only matters if it's continuous, which it was. That equals 3. And that equals the limit from the right of f prime. And that's all I got to show. It's continuous. And the derivatives meet, so f of x is differentiable. All right. You don't need to write in words. If you show me you're doing this, then that's good enough. Like, I understand what you're doing. Okay?